Arithmetic function, let f be a function from z plus to c, where z plus equals set of all positive integers and c is the set of all complex numbers. Then f is known as arithmetic function or number theoretic function. Let's take one example of this. Suppose tau is a function from z plus to z plus. This tau is the letter, Greek letter known as tau. So the function we are defining is as equal to number of divisors of n, including 1 and n. So let us take one example. Suppose we want to find the value of tau of 18. It simply means that how many divisors are there of 18, including 1 and 18. So what are the numbers which can divide 18? 1 can divide 18, 2, then we are having 3, then we are having 6 can divide it, 9 can divide, 18 can divide, and if you count in total, you can see here 1, 2, 3, 6, 9, 18. So how many they are in total? 1, 2, 3, 4, 5, 6. So they are 6 in total. So we'll write tau of 18 as 6. Similarly, tau of 20 is there. So what are the numbers which can divide 20? So they are 1, 2, 4, 5, 10 and 20. So total how many are there? 1, 2, 3, 4, 5, 6. So that will be also 6. So tau of 20 is 6. So this is how we define arithmetic functions. And this function which we have gone through, that is also known as divisor function or number of divisor functions, and is very important one. Next we'll learn what are additive and multiplicative functions. So first let us learn additive function. Let f is a function from z plus to c be an arithmetic function. Then if for any two positive integers, say a and b, if we are taking them in such a way that their SCF is 1, and in that case if f of a into b is same as f of a plus f of b, then f is called additive function. Then we have completely additive function. Then in that one, simply instead of this, will not consider this condition, that is SCF of a and b is 1. So they can be any two positive integers, and if in that case f of a into b is same as f a plus fb, then we say that f is completely additive function. So this extra condition is not there, that is SCF of a and b is 1. That is not necessary. It may be 1 or may not be 1. So in both cases it should be true. Then we say that the function is completely additive function. Then next we'll, in the same way, other function we are learning, that is multiplicative function. So what is multiplicative function? Let f is a function from z plus to c be an arithmetic function, and for any two positive integers, say a and b, if f of ab is same as fa into fb, provided the condition that the SCF of a and b is 1, then it is said to be multiplicative function. Then we are having completely multiplicative function. What is that? Same condition as above, but the condition the SCF of a and b is 1, that is not there. So if a and b belongs to the set z plus, that is they are positive integers, and f is an arithmetic function, in that case if we are getting f of a into b as fa into fb, then we say that f is completely multiplicative function. And remember that here the condition that the SCF of a and b is 1, that is not required. It may be or may not be 1. So in both the cases it should be true. Now let us take one example. Suppose we already have gone through the arithmetic function tau. So tau is, we know what is the function tau. Tau is defined as the number of divisors of n. So let us check this with 12. So we'll check whether tau is multiplicative function or completely multiplicative function. So we are having tau 12. So first of all we'll find tau 12. So what are the divisors of 12? They are 1, 2, 4, 6, 12, 3. So total, if you count them, they are how many? 1, 2, 3, 4, 5, 6. So there are 6 in total. So tau of 12 is 6. Tau of 12 means simply how many numbers can divide, how many positive integers can divide 12. So they are 6 in number. Now next we'll split this 12 into two different cases. First one is 12 equal to 3 into 4. Why we have taken 3 into 4? Because in this case the SCF of 3 and 4 is 1. Then we'll take another case in which the SCF is not 1. So 2 into 6 is 12. So but we can see that here the SCF is not 1. So now in this case tau of 12 will find, we have already obtained that is equal to 6. Then let us find tau of 3. What is tau of 3? Number of divisors of 3. So how many are there? There are only 2. That is 1 and 3. So tau of 3 will be 2. then tau of 4, number of divisors of 4. So how many positive integers can divide 4? They are 1, then 2 and 4. So total will be 3. So tau of 4 is 3. Now let us multiply these two, tau of 3 and tau of 4. So that is 2 into 3, that is 6. And also tau of 12 is 6. So both are equal. So what we can say from 1 and 2, that is tau of 12 is same as tau of 3 into tau of 4. But this 12 we can write as 3 into 4. So tau of 3 into 4 is equal to tau of 3 into tau of 4. So we have come to this same concept which we have applied here, as f of a into b is equal to fa into fb. So therefore we can say that tau is multiplicative function. Now let us check whether it is completely multiplicative or not. So that is why here we have taken the two, we have split it 12 in such a way that their SCF is not 1, because for SCF equal to 1 we have checked it. Now we have to check for SCF not equal to 1. So if it is true for not equal to 1 also, then we will say that it is completely multiplicative. So we will find tau of 2. Tau of 2 means number of divisors 2, so they are 1 and 2, so the value is 2. Then we are having tau of 6. How many numbers can divide 6? 1, 2, 3 and 6. So tau of 6 will be 4. Now we can see that if you multiply tau of 2 and tau of 6, what we will get? 2 into 4, and that is 8. And what is tau of 12? Initially we have obtained, that is 6. So we can see that also we can write tau of 12 as 2 into 6, so that is 6. So what we can see from this one, that is from 1 and 2 we can say that they are not equal, that is tau of 12 is, or tau of 2 into 6 is not same as tau of 2 into tau of 6. Therefore tau is not completely multiplicative function.